This is a electrostatic potential energy problem. And so these are a little bit different. First off, the mass isn't going to cancel. And second off, we've got to be very careful of the signs and the charges. Okay, in this case, we don't ignore the minus signs typically. Okay, strictly actually. Okay, here we go. Okay, so these are two positive charges approaching each other. One of these charges is fixed, which makes the problem pretty simple. Okay, so here's a 160 microcoulomb charge that's fixed. It can't move, right? Fixed. And then here is this 230 gram charge flying along, right? It's going pretty fast, going freeway speed, right? So here it's going 34 meters per second when it's 2 meters out, right? Let's see, 2 meters away, right? So then the question is, when it's 1 meter away, what is its speed? So let's answer this first question, right? Let's answer what is its speed. So it'll be going slower when it's 1 meter away because it will have more electrostatic potential energy. Okay, so we want to know what is its speed here. Okay, so when this mass is here, its total energy is 1/2 0.230 34 squared, and then its potential is K. Notice that this is not negative, right? The negative, the sign of this term will come from the polarity of the charges. Okay, so this is plus K, 160 microcoulombs. Remember, micro is 10 to the minus 6th, right? And then 160 microcoulombs. They're both 160 microcoulombs, right? Okay, positive charge, right? Divided by, all right, and then this is 2 meters. So this is the total energy of it when it's 2 meters away, right? And then we want to figure out the velocity when it's 1 meter away. So that's going to be 1/2 0.230 v squared plus 160 microcoulombs. 160. And then that's divided by 1.00. All right, there we go. Now K is, of course, 8.99 times 10 to the 9th. And notice that these guys are both positive, right? So this term here is going to be positive. You definitely don't ignore the sign on the charge. Okay, so these are going to be positive potentials. So here it's going to be going slower because the coulombic force has slowed it down, right? All right, so here we go. Let's solve this. This side is so 0.5 times 0.23 times 34 squared is 132.94. Hold on here. Got to draw the line of algebra. Got to draw a line somewhere. 132.94. And then this term here is 8.99 E9 times 160. Hi, Jamers. E minus 6. Yeah, you just need a little attention, don't you? All right, times E minus 6. Okay, divided by 2. 115 is 1/2 0.230 e squared plus, and then let's figure out this term here, and of course just go there, make it a 1. This is 230.144. Not surprisingly, it's twice that, right? Okay, and now we're all set. Now we can solve for what this velocity is, okay? So it's going to be this guy plus this guy minus this guy. I've got 17.868 is 1/2 0.230 v squared. Okay, so what do we got to do? See, times 2 divided by 0.23 raised to the 0.5, 12.46 meters per second. Yay! Okay, there you go. So when you set these kinds of problems up, it's just 1/2 mv squared plus k qq over r. Okay, don't ignore the minus signs and the plus signs, right? That's important. Okay, had this say been a negative charge, this guy be negative and that guy be negative, and you'd actually get a higher velocity when it's 1 meter away. All right.